Hey everybody, welcome back. So I'm Rob, and this is a course on introductory statistics for the psychological sciences. And this is the third part of a three-part lecture on how to conduct one-sample t-tests. And in this part, we're going to be going over how to conduct a one-sample t-test when you only have raw data. This is important because in the real world, there typically aren't just sample means and standard deviations floating around. And we collect raw data from a sample of participants. And so this is valuable because it shows you how to conduct a one-sample t-test in that precise situation. So as always, we've got over here are the PowerPoint slides. And then up here is our virtual whiteboard. And if you find this video helpful, don't hesitate to like and subscribe. And don't forget to hit the notification bell in the event you want to receive updates on newer videos just like this one. So, okay, let's dive in it. Okay, so let's just extend the example that we had started using in the second part of this lecture. So this is the one where you're trying to help children read at an earlier age, and so you implement some technique to see if it changes the age at which they utter their first words. So let's just review the problem. It's been tweaked slightly. Right, so you developed a new technique in hopes of helping children start reading earlier. The average age of first word utterances in your town is 13 months. And you don't know the standard deviation of that population, right? So that's the key where you know that you need to conduct a one-sample t-test instead of a z-test. If you were given the population standard deviation, then you would conduct a one-sample z-test. But since it's unknown, we have to estimate it. And we estimate it with the standard deviation of our sample. So you want to test your hypothesis that your technique would change the time of first word utterance. To this end, you randomly select a sample of 15 children from your town, implement your technique, and then record the time of first word utterance in months since birth. Okay, notice there is no mean and standard deviation for your sample in this question. So we're going to have to solve this with the raw data. Now, the procedure for conducting a one-sample t-test when you have raw data is essentially identical to how you would do it if you were given a mean and a standard deviation. You would set up your hypotheses the same way, use the same t-distribution table to determine your t-critical value. You would write a decision rule for your hypothesis test based on your t-critical value. But then when you get to the obtained value of t computation, it's going to be slightly different. We're going to have to integrate sum of squares calculations into this. The difference is all in the denominator. So, and then of course, after you have t obtained, you would use that with your decision rule to determine if you reject or fail to reject the null hypothesis, and then write it up in APA style. But those latter two steps are identical to what we covered in the prior video. So let's move into how one would compute the obtained value of t when you are only given raw data. So the equation is slightly different. So t obtained is equal to the sample mean minus the population mean over the square root of the sum of squares divided by n times n minus 1. So why don't we write that down on our virtual whiteboard. Okay. And then in order to compute this sum of squares value, we're going to need the sum of squares formula, which if you remember, it's the sum of x squared minus the sum of x squared divided by n. Okay, so let's look at our raw data. Whoops. So we can see, each of these rows is a case or a participant, and these x values represent the age in months at which the children uttered their first word. So the first thing we're going to have to do, and this may seem very familiar to you, is we need to compute the sample mean, x bar. So we do that, we get 165. Then we need to create a column of squared x values, right? So this is these are the squared values for each value of x. And then after this, we need to compute the sum of the squared values for x, right? And we get 1971. Okay, so here's our t-obtained equation. And now we have all of the information that we need to compute the sum of squares, right? So let's plug in to our equation right here. So sum of squares is equal to the sum of x squared, which is 1971, minus 165 squared divided by 15. And this equals 1971 minus 1815. And so when we resolve that, we have a sum of squares equal to 156. Okay, and now we can just plug that sum of squares value into our t-obtained equation. So t-obtained in this instance is going to be equal to 13 minus 15, right? So 13 is our sample mean, and 15 is our population mean, divided by the square root of 156 divided by n times n minus 1. So this is going to be minus 2 over the square root of 156 divided by 15 times 14. So this is equal to minus 2, minus 2 divided by the square root of 0.7429, which is equal to minus 2 divided by 0.8619. And so we get a t-value of 2.3205. Actually, that's a negative t-value. Okay. So that's how you compute the t-obtained score whenever you only have raw data. So let's see on the slide. We've got the same information as on the whiteboard. And we get negative 2.32. So we would then take that t-obtained value, compare it to the t-critical value, which was minus 2.145 or plus 2.145. And in this case, we would reject the null hypothesis, which would suggest that the children in our sample likely were not selected from the same population as the population of children in our town. There's something going on with that's making them read at a much earlier age. And that could either be 5% of the time, it could be sampling error, that you just accidentally selected 15 children who had very early first word utterances. But 95% of the time, it's not going to be due to sampling error. It's going to be due to the fact that you implemented your technique. And so we're able to make a claim that this technique we can infer that the population of people that your sample represents, right, are different, which means that this technique would work for all children in your town and help them read at an earlier age. So that wraps it up. I hope you enjoyed this lecture on one sample t-tests. And if you found it helpful, like and subscribe. In the next lecture, we're going to be going into correlated groups t-tests. And we'll also talk a little bit about the nature and computation of confidence intervals and why it's so important to report confidence intervals in an APA style write-up. Okay, thank you.